Hello, receiving teachers, students, and class.
Hello, Mr. Valerie.
Thank you. You may sit down. Right. We looked at our last lesson. Can someone tell us about our last lesson? What did we do in our last lesson? Okay, let's have one of your friends front.
How much is enough?
How much is enough? What did we do in that lesson? How did we find how much is enough? What did we do in our lesson yesterday? Iowa, thank you, Iowa, will give us our answer.
We did about observing the substances like sugar or coffee.
How did we observe the substance? What did we do? How did we observe the substance? Someone would like to help? Okay, our friend at the corner. Friend.
By identifying and describing physical properties of liquid.
Yes. What else did we do? What did we try to find out? Okay. Yes, we have many hands up. Okay, we'll go for the first one.
The solubility of each substances.
Right, the solubility of substances. Thank you for that answer. Anything else that we looked at? We looked at solubility. What was the other thing that we also looked at? Did you use time? Why did we use time? Why did we use time? Diane?
Because to see how long the substance will take to dissolve.
Very good, thank you. So we use time to see the rate of its solubility. How long does it take to dissolve in the water? Okay, I have 3 containers here. 3 beakers. We have A here, B, and C. Now, I would like you to have a look at the first container, A. Each of this container contain about 400 milliliters of water. Container A, have a look at container A. Now container B, let's have a look at container B. Container B also has about 400 mils of water, but there is nothing inside. So I have salt here. What do we call the salt in the terms that we learned yesterday? Is salt? Yes, it is salt crystal. Is it a solute or solvent? Is it a solute or solvent? What? Somebody answer, please. Oops. Okay, we have salt here on the teaspoon. So, a teaspoon of salt, and I'll pour it in like we did yesterday. And you just have a look at it. So we have a salt there. Have a look at this salt. What is happening? Okay. Now let's stir. Okay. Come up to the front, hold this and show this to the class. Hurry up. You tell them what about the salt. Has it all dissolved or not dissolved? Put your hand underneath. Okay. Tell them that describe the content. Is the salt in there or has it all disappeared? Have a look at it and tell the class.
Disappeared.
All the salt has disappeared. So what kind of solution or what do we call it? Thank you, you may sit down. What is it? It is a solvent. Thank you. Yes. Eddie?
Solution.
Right, it is a solution. When something dissolves altogether and when there are no particles left, it is called a solution. Now this time, C. Right, it took me 5 seconds to dissolve all that. So let's see this one. If we can dissolve everything. So what kind of solution is A? And the last one, C. So gone. Okay. Put some more. Okay, let's have a look at container A. Container A. What kind of solution is this? Right, it is a suspension. This is a suspension where the liquid is cloudy or looks milky. So this type of solution is called a suspension. The next one is the B, beaker B, is solution. There are no more salt particles left behind. All has dissolved, so it is called a solution. Any questions? Okay. And the last one. Do we have salt crystals still in there? Yes, we do have some salt crystals at the bottom of the beaker. So what kind of solution is this? Okay, good. Let's have the answer.
Saturated solution.
Right. Saturated solution. Thank you for the answer. Saturated solution is when there are particles left behind, meaning the water cannot dissolve any more of those particles. Okay, thank you. Clear? Any questions you need to ask? No. Right. Teachers, our lesson topic for today is volume. Shapes. The shape makes it hard. We'll be going through the activity. You will be following the instructions in your groups. Please clear out the table and have your apparatus on the table, in the center of the table. Okay. Right, you should have a measuring cylinder. A measuring cylinder which you should have a container, half container, and a pebble or any other regular shapes that you have or regular shapes that you have. So you will be using that. Now, our measuring cylinder, if the measuring cylinder is not clear, you may use colored liquid. So we will be using colored liquid just for us to see clearly the quantity of water in the measuring cylinder. Now, one point that I would like to make clear is when you are reading the measuring cylinder, where do you read? Okay, let's say this is the measuring cylinder. The water level is here. Okay, let's blow this one up. Yeah. And the measuring cylinder here. The water level looks like this when you look closely. The surface of the water it looks like this here. So what do you call this? This surface below here. What is this surface below here called here? This curve here. What is the curve called? This curve is called right, good. Some of you know that. It is called the meniscus. This is where you read from. Below the curve. You read below the meniscus. On the edge of the measuring cylinder, you will see that. Oh, thank you for your correction. C. Meniscus. So when you are looking at the level of water, you look at the meniscus, below the meniscus, and you will take your reading. So do that, read that carefully. Okay. Okay, the first group has been done. your empty container, fill your empty container with the colored water. Just fill halfway and pass to the other group. Get ready for instruction number 1. Container, empty container, empty container. That's okay. From the empty container, you pour it into the measuring cylinder. Okay, that. Write your instruction number 1. That is your instruction number 1. You have 30 seconds for the instruction. The next instruction. Did you take the reading? Take the reading. Take the reading. Take the reading. Take the reading. Where's the reading? Mic on. Whichever. Okay, put the marble. Okay, put the marble. Did you put in the marble? Pebble. Did you take the reading? Okay. Finish. Right, your answer is still in milliliter. Your answer is still in milliliter, so you will have to do a conversion of the answer to the correct unit. That's your next step. All right, you should have your final answer. Make sure you're working out straight. We will have a few groups to come up to present the calculation of the volume of solid. Okay, any group that has been finished, show us the calculation of finding the volume of solids. Right, we have one group here, good, thank you. And when you finish, you explain to the class. Just show the working out. Any others who finish want to be after this group? The group? Or this group? It explains. Hurry up. Mike.
Our first reading was 71 milliliters, and the second reading was 73 milliliters. So the formula said you have to subtract second reading and the first reading and find the volume of the solid. So 73 minus 71, it's 2, and then you have to change this milliliter to cubic centimeters. So 1 milliliter equals 1 cubic centimeter. So 2 milliliters multiplied by the 1 cubic centimeter equals 2 cubic centimeter.
Thank
The
you,
answer
Daniel.
of the volume of solid is 2 cubic centimeter.
All right. What was your solid? The marble. Okay. Thank you, dance group. Let's have one more group. One more group. Okay, Happy's group. Any else? All right. Well, if you finish your calculations, then you can put your calculations on your workbook and have the diagram drawn of what you have done. Have the diagram drawn and put your calculations next to the diagram that you have drawn. And you may pass that up to your teacher for correction. Okay, thank you. Let's have a look at their reading. Okay, 73 is the second reading. But when you are recording, this is exactly 73. So on your measuring cylinder, it is 73, exactly 73. But you also need to indicate a decimal point. So if it is 73, it is 73.0. Others will read other digits after the number. So you need to put the decimal point. It is very important for you to put the decimal point. So some of you may come up with not the fixed amount. You may come up with 50.1 or 54.9 on your measuring cylinder. That is why it is important that if you come up with a fixed number, you must put the decimal point and a 0 behind the decimal point. Now your symbols, your cubic centimeter here, a tree should be just above the letter M, not far away or to the side, not close. When you're writing, the third thing is when you're writing the unit, the symbol, you should write clearly a small letter M and L. So this looks like they are the same. So differentiate the size of the letters. Any question? Okay. We have 3 summary points. Your first summary. Like this is someone read and someone record. And then you can share the summary with your friends. Next summary. Anyone would like to give us the key phrase? Anyone willing to give us the key phrase for today?
Volume.
Volume? Yes, volume. Volume, the shape makes it hard for us to find the volume. Very good, but we found the volume of the shape, which is the objects that we just used in our activity. Right, our next lesson, receiving teachers and students, is how hot is this liquid? We'll be needing a lot of equipments. Some of the things you will need to make for your own. Some you will have to bring with you to school on the next lesson. And these materials are the first group of materials. We need a tripod, wire gauge, beakers or glass jar, thermometers for each group, a stopwatch. If you don't have stopwatch, watch is okay. Rags. We'll also need a bucket of water. The next list continues to a retort stand and a clamp. If you do not have a retort stand and a clamp, you can make an improvised model of a thermometer holder. You will need water, cooking oil, paint, bleach, and engine oil. These are the liquids that you will use. That is water, cooking oil, paint, bleach, and engine oil. All right, with that, thank you receiving students and teachers, and thank you class. Thank you, welcome. You may sit down. Right, you will bring yourselves